is for Chapter 2 in MTB 1370, and it deals with a section on proportions. We're going to use proportions a lot as we proceed through the course, so it's good to have a solid understanding of exactly what a proportion is and how to write them and solve them. So all a proportion is an equality of two ratios. So two ratios that are equal, or it's an equation between two ratios. So if I had something like 7/10 is equal to 21 over 30. Each fraction is called a ratio. And when we set the two ratios equal to one another, the whole thing is called a proportion. So it's an equation or an equality between two equal ratios. And you notice if I have 7/10, that is equal to 21 over 30, because you could just multiply the first fraction by 3 over 3, and you would get the second fraction. There's other ways that we're going to talk about to show that they are equal as well. So one way to write a proportion is one fraction or ratio equal to another one. Now sometimes, though, we can write them, as this says, with a double colon. So you could write this same ratio, clear the page. You could write that same ratio a slightly different way. And that is with the double colon sign. So I believe I had 7 is to 10, so that's one ratio. And the other ratio was 21 is to 30. But instead of putting an equal sign in between them, you could use a double colon. And sometimes we read this 7 is to 10 as 21 is to 30. Now, the next slide, I believe, we'll talk about special names for these terms. So let's go to the next slide. Now here is a proportion. Remember, this whole statement is a proportion because we have one ratio, 5/10, is equal to another ratio, 10/20. And like I just mentioned, we could read that 5 is to 10 as 10 is to 20. So these three proportions, top one, this one, and this one, are all saying the same thing. Normally, when we write the ratio with a colon, you wouldn't see an equal sign in between them. You would see the double colon in between them like we had up there. But those are three proportions. They're all saying the same thing. Now, when you do have a proportion written with the colons and the double colons, we have some special names for the terms in the proportion. These two middle ones are called the means. They're called the means, and you'll read that in your book as well in chapter 2. And the outer ones are called the extremes. If you look at the means, 10 and 10, all that is the first fraction's denominator and the second fraction's numerator. Those are called the means. The first fraction's numerator and the second fraction's denominator are called the extremes. And if the two fractions are truly equal, if you multiply the means together, that product should be the same as the product of the extremes. So in other words, 10 times 10, that's 100, and 5 times 20 is also 100. So if the two fractions were not equal, then those products would not be equal to the same number. So again, it's saying we multiply the tens together, those are called the means, we get 100. If we multiply the extremes together, we get 100. So that's where you hear the word cross-multiplying. So when you have a proportion, you can cross-multiply, and those two values should be equal to one another. Now, the reason that is helpful is to do those cross products is because generally when you have a proportion, one of the values is not known, one of the numerators or one of the denominators. So multiplying across like that and getting those cross products will give us an equation that will be pretty easy to solve. So again, 10 times 10 is 100, 5 times 20 is 100, so those two fractions are indeed equal to one another. But as I said, normally one of those values is unknown, so we might use a variable such as x. And we have to find the value of x. We have to solve for x. So here's one example, and we'll try to do another one as well. If we had 1/4 is equal to something over 8, well, one way to find that something, that x, is to multiply the extremes to get 8, multiply the means to get 4x, and then you have the equation 4x is equal to 8. So if we want to isolate the x, since it's 4 times x, we would divide those sides by 4, as they did here. And when you divide by 4, you get 1x, which is just x, is equal to 2. X is equal to 2. So that numerator of that second fraction is 2. And I think that makes complete sense, because if these fractions are equal, 4 times what is 8? Well, 4 times 2. So you'd have to multiply the first fraction by 2 over 2, and 2 times 1 is 2. So that shows you x had to be 2. Now, the denominators are not always multiples of one another, so you can't always check it that way in your head. But in this one, you could, because 2 times 4 is 8, so you also have to multiply the numerator by 2. 2 times 1 is 2. Let me give you another one here. If I had 3 is to 5, and when we get to our application problems, that might be 3 milligrams to every 5 milliliters, and the other side might be, well, we don't know how many milligrams are in 17 milliliters. So it might be milligrams to milliliters on both sides, and we have to figure out the x, the number of milligrams up there. So this is an equation. It has an unknown in it, so the directions usually would say solve. That's what we do to equations where we have a variable. And to solve that, we cross-multiply. We get 5x. That's the product of the means. 3 times 17, I believe, is 51. That's the product of the extremes. And since we have 5 times x is equal to 51, to isolate the x, we simply divide both sides by 5. The 5's over there divide out, and we get x is equal to 51 over 5, which we would not leave it that way. 5 goes into 51 10 whole times, and that would take you to 50, and then you'd have a remainder of 1. 51 minus 50 is 1. Then we have to divide by the divisor, the denominator of 5. 10 and 1/5. So that's an example of solving a proportion when you have an unknown in the proportion.